Good evening, everyone. My name is Ayowale Shoyemi. I'm a postgraduate student. I'm a PhD student in polymer and coating technology, and my research advisor is Professor Vijay Manari. So welcome to the Coating Research Institute at Game Above College of Engineering and Technology, and this is our laboratory. So my research project is Bisphenol-A free sustainable epoxy resin for coating. Bisphenol-A free sustainable epoxy resin for coating. I will simply introduce the topic. Bisphenol-A is majorly used in the production of epoxy resin because it has a lot of active material like adhesion and some other active property that is needed in coatings. But Bisphenol-A is toxic. So my research project is how can we replace Bisphenol-A that is toxic with other material. So I'll be using a bio-based material. I want to replace the Bisphenol-A with bio-based material. So I'm synthesizing an epoxy resin with a bio-based material. These are my raw materials. This is Sorbitol polyglycidia ethyl. This is the commercial name. Sorbitol polyglycidia ethyl has a reasonable amount of bio-based material in it. And this is rosin. It's purely bio-based material. The whole material, everything is bio-based. Then these are the acid. This is benzoic acid, a monoacid, and this is isocyanic acid. This is a diacid. These are the solvents that I am using for the reaction. These are the reagents that have been prepared. These are the catalysts for the reaction. Then these are the indicator, crystal violet and phenolphthalein. This is the curing agent. This is the cross-linking agent. Then this is the last epoxy resin that I have synthesized. This is the titration setup to monitor the epoxy value and the acid value. This is an ongoing synthesis. This is the one that I am producing presently. It has a temperature monitor. It has a rotating valve to ensure there is a uniform mixture in the reaction solvent. In the reaction, then it has water inlet and water outlet to ensure the temperature is maintained. For every epoxy resin that is being produced, it undergoes this process. So how do we start? This is how I start the process. There is an equivalent amount of sorbitol polyglycidia ethyl, rosin, benzoic acid, and isocyanic acid is weighed. We have what we call equivalent weight. The equivalent weight of each of these raw material is weighed on the weighing balance. Then after weighing each of the raw material, I take it into the reaction device here inside the hood. The whole reaction takes place in the hood. After weighing them, I charge the material into these flasks, and I do this setup. Nitrogen is being introduced into this place. The essence of the nitrogen is to prevent oxidation reaction, to prevent oxygen from the reaction. We don't need oxygen in this reaction. So the reaction temperature, everything reaction to ensure there is uniform mixture, then water and everything is set up. This reaction, this whole synthesis takes about 5 to 8 hours. So for every epoxy resin that is being synthesized, it takes about 5 to 8 hours to produce an epoxy resin for the reaction, and the reaction temperature is 120. So what happens while the reaction is taking place, and every 1 hour sample is taken from this reaction mixture with the aid of this syringe. I take the sample to monitor, to check the value of the acid value, to check the acid value and the epoxy value. At interval, this is necessary because the major reaction that is taking place in the vessel, in this reaction mixture, in the flask, is esterification reaction and eterification reaction. These are the two reactions that is occurring, which needs to be monitored. The last sample I took from the reaction flask, this is the last sample I took from the flask. So to determine the acid value of this sample, a weight sample that has been weighed here, mixed with the reaction solvent, then I titrate with potassium hydroxide. This is potassium hydroxide in the burette. Let's quickly go through the titration. The indicator I use is phenolphthalein. So as soon as there is color change in the reaction, I will stop to know the exact value. Okay, the color has changed, so I stop the reaction. So at this point, we call this point an end point of the reaction. This is the end point. I stop the reaction at this point because there is a color change. Phenolphthalein is the indicator that I use. So I read the value the initial value and the difference between the final value and the initial value is the volume of potassium hydroxide that is consumed in this sample. So with that, I will calculate my acid value. I do the same thing for the epoxy value. To check the epoxy value, I calculate through perchloric acid. Then I determine that, I record the value. I use the formula in a standard. I use the formula to calculate each of the value of the acid value and the epoxy value. That is done at interval every 1 hour to ensure to monitor the rate of reaction. So after that, this is the last epoxy, bio-based epoxy resin that I produced last. This is the last one. It's an ongoing reaction. So an equivalent weight of this sample with a cross-linking agent. This is the cross-linking agent that I'm using. Equivalent weight of each of the cross-linking agents and the sample is weighed into this. This is the sample at different ratio, 90 to 10. 90 of the epoxy bio-based resin that I've produced with 10 of the cross-linking agent. This is another ratio, 80 to 20. 80 of my epoxy resin and 20 of the cross-linking agent. So with this, I'll determine further analysis on it. The last one I did is this. I took a sample from this, a weight sample, to determine the FTIR. I used the FTIR machine to check the IR of the sample. The IR machine is over there. We quickly go there and see how we use the machine and the extent of the machine. So this is the FTIR machine. What this is all about is we use this to determine the major structure, the major functional group present in the synthesized epoxy resin. The last sample I did, I just want to quickly open the last sample. I did the structure of the last sample I did. We use this to. So this is the machine. This, okay. I want to remove this. I'm trying to open. Okay, this is the last sample I did for the FTIR. So this is what FTIR output looks about. This is the machine. This is where we introduce our sample. We have a plate that I will put a weight of sample in the plate. Then we'll produce the plate here. We'll put it on and we'll run the sample. This is the output. The essence of this is to determine the key functional group present in the synthesized compound. So for every spectra, for every line here, we explain is equivalent to a particular functional group. For instance, when we have around 1650 is that of C double bond O. That is the carbonyl group. We call it the carbonyl group. It shows that there is carbonyl group in the synthesized epoxy resin. Then we have other ones like CH3 group. We have the CH and other ones. A sample of these will be displayed on my poster, and I will do further explanation on that. So from the whole process so far, it is obvious that we can synthesize, we can use the bio-based material to produce an epoxy resin without having bisphenol-A, which is toxic in the whole synthesis. A series of tests has been done. It has been postulated already before the start of this experiment. That's why I use rosin, which is known to be a good bio-based material in the synthesis of the epoxy resin. Thank you very much.